So yesterday we have finished up to here. We have derived the relation Ohm's law in vector form, we say. J is sigma E. So this is our sigma. N is square tau over M is sigma. Yes, up to here, any doubt? Anyone have to ask? Any question? Did you understand everything? Yes. No doubt. Or you didn't get time to revise. So we'll continue from this question number 4. So this 4 says this E means what? J means what? I over 8. If you say only magnitude, that is N is square tau over M, and this is potential difference over L. So this equation says this V will be how much? This will come here, M into L, N is square tau A. So this is resistance. B is IR. So this is resistance. So resistance of conductor is ML N E square tau A. This is M N E square tau L over A. This depends only on nature of material. How many free electrons are there per unit volume? Mass of electron, charge of electron. Here E means positive we have to take. Tau is the relaxation time, and that will depend on number of free electron as well as the temperature. So that's why resistance we say it depend on length, it depend on area of cross section, it depend on nature, it depend on temperature. So these are the 4 factors which we have learned, and we can explain on the basis of this free electron theory also. Now what will be this? So R is this much, rho will be now M over N E square tau. Sigma is from here, inverse of this. So sigma is N E square tau over M. And eta over M is mobility. So this can be N E mu. And you know, mu is eta over M, mobility. So these are the different relations which we have already derived, means which we are knowing from before, but only the thing we have derived now in terms of mass of electron, charge of electron, and relaxation time. That was the new thing. And we can explain the dependence of this R and rho on temperature on the basis of this expression only. So R depend on L, depend on A, depend on nature of material, because nature of material mainly the number of free electron per unit volume, as well as the average time interval between two collisions. Sometimes we may be asked what is the free path and what is mean free path. Free path means distance traveled by free electron between two constitutive collisions. So as we know, different electron is colliding in different time. So for first electron, it may be this lambda 1 will become drift velocity into T1, lambda 2 drift velocity into T2. So like that it will be. Generally, we express mean free path. So mean free path means mean velocity and mean time between two constitutive collisions. Is Vt into relaxation time. So this lambda may be Vt means J over Ne and relaxation time, or I by A Ne tau. Ne by tau is mobility, so it can be I by mu E. No, E tau by Ne, no, it is wrong. Only this one. This resistance inverse will be the conductance C. So C will be 1 by R, that is this by this. We are knowing all the relations. Now, factors factors on which R depend. C is how much? 1 by R only. That you are knowing, there are 3 or 4, whatever you may say. So R is directly proportional to length of the conductor. R is inversely proportional to area of cross section. Third is nature of material. And the fourth is temperature. Nature of material, how will it be affected? Because it depends on number of free electron per unit volume. We'll write this expression, then we will. R was how much? What was the expression for R?
ML.
M over
Sir, ML.
N square tau.
A.
E. So R by L by L.
L.
This one.
Yes, sir.
So this rho is M over N square tau, and sigma was N square tau over M, that is NeV. So nature of material mainly what it means? This N, number of free electron per unit volume. If number of free electron per unit volume is more, it will be a better conductor, and hence its resistance will be less. So more number of free electron per unit volume. Resistance will be less. That is mainly the nature. It depends on dimension, length of the conductor, area of conductor, and the nature. So if you compare copper and aluminum, copper has got more number of free electrons per unit volume. So each atom is giving only 1 electron, then also number of free electron per unit volume will be more. So copper will be a better conductor in comparison to aluminum. Now, fourth factor we have to discuss in detail. So effect of temperature. On this R and rho. Because rho depend on these two things. If you are asked factors on which specific resistance depend, then only these two. The specific resistance does not depend on the length of the conductor, does not depend on the area of cross section. So these two will be the factors on which rho depend. Rho or sigma. So only these two factors will be there. So mainly if the resistivity is more, resistance will be more. So mainly we are going to discuss this resistivity. How resistivity will be affected by the temperature. So I know this rho is m over n e squared tau. So if tau is more, resistivity will be more, provided there is no change in n. So in case of metallic conductor, with rise in temperature, there will be no change in the number of free electrons. For metallic conductor, there will be no change in n, that is number of free electrons per unit volume with rise in temperature. But this tau decreases. So when there is rise in temperature, naturally what will be? The average speed of free electron will increase. Kinetic energy of all the free electrons will increase. Kinetic energy increases, that means velocity increases. If velocity increases, then within two collision, while moving from one atom to other atom for colliding, time will become less. So with rise in temperature, this tau decreases. Naturally, what will be rho? As a result, rho increases. Rho increases means R will also increase. That is in case of metallic conductor. In case of semiconductor, maybe p-type, maybe n-type, semiconductor that we will discuss afterwards. So for semiconductor and insulators, this number of free electron increases. With rise in temperature, number of free electron increases. So more number of electron comes to the, we call it valence band. That is, more electron will become free with rise in temperature. So for semiconductor and insulator, what will be? Number of free electrons per unit volume increases with rise in temperature. So in this case, n increases, tau decreases. That is the case. But this factor is dominating. Due to this, rho is increasing. Due to this, rho is decreasing. So as this factor is dominating, that's why finally what will be? Rho will decrease. So in case of semiconductor or insulators, insulator means whose resistance is very high. They are insulators because they are having very less number of free electrons. So for semiconductor and insulator, what will be? This N will increase. due to the breaking of covalent bond or due to thermal excitation, more electron will become free. So this will dominate over this factor. As a result, it increases. Okay. Now there are some metallic alloys for which there is no effect of temperature, and those metallic alloys are used for making standard resistance in lab. For certain alloys, manganese, German silver, Australian, there is no effect. So its resistance or resistivity does not change. It has different type of alloy. It is a mixture of different materials. So in this case, what happens? N increases with rise in temperature and tau decreases. The ratio of increase and decrease is same. If N increases by 5%, then tau decreases by 5%. So result is same. No effect. Not by 5% same. Whatever the ratio may be, if N become double, tau become half. So that will become same. It remains same. So this type of material is used for making standard resistance. So in the lab, when we are using 1 ohm resistance or 5 ohm resistance, then inside that hole or coil is there of this type of material. So during winter season also, if it is 5 ohm, then during summer season also it should be 5 ohm only. So this type of material, this type of wire is used for making standard resistance. Its value remains same throughout the year. So whether it is summer season, whether it is winter season, its value will not change. Now, effect on the resistance So when it is stressed, so without changing the volume, if we change the dimension by stretching, by compressing, whatever it is, so if anyhow we change the dimension without changing the volume, then how will you find the new resistance? So this stretching may be of two types. First will be when length is increased and time. Without changing its volume. So when there is no change in the volume, the same wire is stretched. Suppose this is a wire, its length is L, area of cross section is A, its resistance is R. Now this wire is stretched. So this L dash is N times N. We are interested to find what is the value of this R dash. So what will be now? So you know this R is rho L by or first. Okay. And this R dash is rho L dash over A dash. As there is no change in the material, so R is this much, R dash is this much. So in general, if suppose everything changes, then this one will be how much? L dash over L into A over A dash. If this is the two wires of same material, then rho will cancel. In general, what will be, if they are of different material and you are asked find the ratio, then ratio of this rho will also come. Here this may be rho dash by rho, we can say. So general relation is this one. In this case, it will become L dash by L into A over A dash, since rho is equal to rho. The same wire is stretched, so there is no change in the resistivity. Now you know the volume is same. A into L will be equal to A dash into L dash. That means A over A dash will be L dash over L. So from first and second, what you will get? R dash over R is, in place of A by L dash, we can write L dash by L. So it is L dash over L whole square, or it may be A over A dash whole square. This is equal to N square, means this L dash is N into L. If you are given length is straight 5 times, 3 times, 1 time, then by that one we can directly, if it is said, okay, length is increased by 10%, then L dash we have to find. L dash will become 1.1 of L. So then this is the general formula. L dash by L over a whole square. Sometimes you will be given this wire is stretched in such a way that its radius become half. Length is not given. Then this one we have to consider. Or diameter. Okay. So in that case, what will be this A dash is given, no, diameter is given this one, or thickness is given, or radius is given, R by N. Then we substitute the value of this. Okay. So here, what will be A over A dash whole square? In place of A, what will you write? So this is pi r square, and this is pi r dash square. So r over r dash to the power 4. R dash is R by N, so it can be N to the power 2. So if you are given the length is increased by this many times, 2 times, 3 times, then 2 square. If radius is reduced to half, then it will become 2 to the power 4, that is 16 times. So if wire is stretched in such a way that its radius become half, then resistance will increase 16 times. Okay, so we will leave up to here. So you start solving the problems. Most of the things we have already discussed. Only color coding of resistance. Ohmic and non-ohmic resistance we are knowing. No? We are knowing that.
Yes.
The conductor or the resistance which follows Ohm's law. The graph will be, okay, next day. Tomorrow we'll discuss that. We have got next class also. Okay.
Thank you, sir.
Thank you.
Sir.
Thank you, sir.